y'all, we're going to move right along to part 5, density and percent error. So what is density? Well, density talks about how much stuff you have in an area. So we've got these particles and these particles. Which is more packed together? Well, let's compare. This would be something, and if you want to add this into your notes, this arrow was left out. So this has a low density. There's not a lot of stuff per area. So there's a little bit of stuff in one area. Notice if I make a circle around this molecule, this particle isn't touching anything. So it's a low density. Versus over here, it's a high density. It's really packed together. So if I look around one particle, I'm going to see other stuff around it. So this is low, this is getting more dense, and then this is super dense. What's the formula for density? Well, gotta love density. So it looks like mass divided by volume. If I take this and I talk about the density, I'm talking about how much stuff per area. So you can think of making like little cubes or little grids. So if I take this little grid, look how many things I have. Well, I've got one whole, this is like a half, a quarter, just over a half. So on average, this has just over 2 full particles in it. If you look around, so like right here, this has 1, half, and a little more. So this has just over 2 particles. If you look here, I've got 1, almost like more than a half, a little piece, and a less than a half. So this is also just over 2 particles per square. So when you talk about, you're saying how much mass or how much stuff per area. So per volume really in density. So if we made it a 3-dimensional area, how much stuff in a given area. All right, so in the lab, we stacked some stuff in my class. You had different colors. Why did this color stay up here and didn't mix with the color down here? Well, let's compare a few things. So what if we had low density on top, high density on the bottom, versus high density on the top, low density on the bottom? In our first scenario, if these particles tried to squeeze through, that wouldn't really happen. Over here, though, I have a lot of stuff sitting on top of not a lot of stuff. So the top particles can actually fall through the open areas in the less dense scenario, this bottom part. So even if you did it wrong, eventually they would flip. Because our top particles would just start falling through, and there would be the final outcome. All right, so let's work through some problems. You want to identify what every bit of the problem is. So this says a sample in the lab has a mass of 4.05 grams and a volume of 6.31 milliliters. What's the density? Always want to use the equation. So what you're solving for is density. Well, that means you probably know the other 2 pieces. Here's the mass right here, 4.05 grams. And here's the volume, 6.31 milliliters. So you plug them in where you need them. 4.05 grams divided by 6.31 milliliters. Notice here are my letters or my units, grams per milliliter. There's nothing for those to cancel out with, so they have to stick around. You do the math and you get 0.642 grams per milliliter. Do not forget the unit. You can't have any naked numbers. All right, if a substance has a density of 3.22 grams per cubic centimeter. Last time I said milliliters, and that's generally talking about a liquid, maybe a gas, but centimeters cubed is literally measuring the length, height, and width. And so what would be the volume? What would be the volume? We're looking for V, so this is going to be our variable of a 52.06 gram sample. All right. So you have 3.22 grams for every cubic centimeter, which I put as milliliters, which 1 cubic centimeter is the same as a milliliter, so that's okay. You don't know how much volume it is. Notice this now looks like a proportion. When you have 2 fractions set equal to each other, cross multiply. So here's how you cross multiply. The top of the left side gets multiplied by the bottom of the right side. The top of the right side gets multiplied by the bottom of the left side. So now I have 3.22 grams times x. That's going to be set equal to 1 milliliter times 52.06 grams. You want x by itself, so you're going to divide by 3.22 grams. If you divide on the left, you have to divide on the right. Notice this whole thing cancels, and over here, if you have grams on the top, grams on the bottom, that cancels. So you just do the math. 1 times 52.06 divided by 3.22, so you have 16.2 milliliters. If you have any questions on this, go ahead and ask your teacher. All right, so it's your turn to answer a few questions, and these are all on your paper as well. We'll be back in a minute to talk about them. Make sure you freeze. All right, so here are the answers to the questions. If you didn't get any of these, you need to go talk to your teacher and see what you did wrong. Let's talk about percent error real quick. This is the formula for percent error. A couple things I want to point out. Experimental minus accepted is in absolute value, so it has to always, always, always be positive. Experimental, that's what you got in the lab. The accepted is what you should have gotten. That's the right answer. So you're not always going to get the right answer because there's always some sort of error, and that's okay, but you just plug in what you should have gotten here. The other thing to do, make sure that you solve for this top part first or put it in parentheses, because if you don't, the calculator's order of operations is going to do it a little off with this. All right, so let's work out a problem. A student determines the density of a substance to be 1.40 grams per milliliter. Find the percent error if the accepted value is 1.36. So this is what you should have gotten. This is what you got. So this is the experimental, what the person got in the lab in the experiment, and this is the real deal, the accepted value. All right, so let's plug it into the equation. First, find the top part. Divide that by 1.36. So either put this in parentheses when you put it in your calculator, or press enter, so 1.40 minus 1.36, enter, then divide it by 1.36. Then make sure all of this is positive. You want the absolute value, so you can do this, or you can just ignore the negative sign if you ever get a negative sign. This one will not, because you have a bigger thing minus a smaller thing. And then don't forget to multiply by 100, because it's a percent. So when you get this, you should get 2.94%. All right, so it's your turn. You've got 2 questions to give a try. So you have to freeze the screen, try the questions. I'll give you the answers in a minute. If you get something different from me, then definitely talk to the teacher and see what you did wrong. Okay, so you did freeze the computer. You've answered your questions. Here are the answers. So you should have gotten 3.40% and 9.06%. If you didn't get that, go see the teacher and figure out what happened. All right, see you in the next video.